Now that you know how to do the law of sines and law of cosines or cosine rule, sine rule, now we're going to look at some story problems that involve both of these. So in the first one, we have angles of elevation to the top of the mountain. Remember, angle of elevation always goes from the horizon up. So it goes from the horizon up. So that's my angle of elevation. And they're measured from two different beacons from A and B at C. These angles are shown on the diagram. If beacons are 1,473 meters apart, how high is the mountain? So we want to figure out what this is. And in order to figure this out, we knew two angle measurements, and we also knew this distance. So taking that information into consideration, I have, in essence, three triangles. I have triangle ABT, I have triangle BNT, and I have triangle ANT. So sometimes it's easier if we just pull apart our triangles to try to look for things that we know. Now, one of the things to remember is when we pull those triangles apart, they typically have something in common. So for instance, if I split these two triangles, ABT and BNT, they both have that exact same side length. So since I need to find my height, I'm going to have to somehow figure out, this is my side length I need, this is an angle I have, I'm going to need to have another side length in order to figure out this unknown side length. So therefore, I'm going to pull those apart, and I'm going to use this triangle to find that shared side. So, clean that up. Pulling apart my two triangles that I have. So ABT is this triangle. And I know this angle is 29.7 degrees. And then I also know this angle here because of this straight line. Since this angle is 41.2 degrees, subtract that from 180, I know this one is 138.8 degrees. And then because I know all the angles in a triangle add up to 180 degrees, I know this angle is 11.5. Now, since I know all of the angle measurements, most likely I'm going to end up doing the sine rule with this one. So then I do have one side length that they told me that we didn't draw on our picture, and that was the 1473. So using the idea of what I need to find, this is the shared side. That's the side that I kind of needed my other triangle to find what my height is. So therefore, I need to find that, which I'm going to call W. So, algebraically, setting up my sine rule, I need to figure out W. So W is to the sine of 29.7 degrees as the side length that I know. Oops, 1473 is to the sine of 11.5. And sometimes it's just easiest to find what you know and then start to look at what do you need. So now I just need W, so I need to get rid of the sine of 29.7, so I'll multiply both sides by the sine of 29.7. So therefore, I get W equals 3,660.622. Now that's not an exact value, so make sure you store that, especially because you're going to need it in your next picture. So now going back to my picture, that was this triangle here. I wanted to find the height, so we called that x. This is 41.2 degrees. I just found that shared side, which is 3,660.622. Again, exact value is stored in your calculator. Because it is a 90-degree angle, you could automatically find this top angle as well. However, I don't need to in this case because I have a right triangle. Since I have a right triangle, I can just do right triangle trig now. I don't have to do law of sines. I don't have to do law of cosines. I can just do right triangle trig. So from this angle, this is opposite. This is hypotenuse, so I'm going to use the sine of 41.2 degrees equals opposite over that hypotenuse, which again you have stored in your calculator. Solving for x, multiply both sides by the denominator. Please make sure that your calculator is in degree form. Since you are typing in the sine of the angle that is in degrees, your mode must be in degrees. So when you type that into your calculator, you end up getting x equaling 2,411.213 meters. And think about what your picture represents. That is the height from T to N. So you just found your vertical height that you needed. If you needed to find something else, you could have done a different trig function to figure out the other side. So that's kind of starting. You've got two different triangles within one, starting to pull them apart. Okay, the next one. This one looks a little scary, but you just have to be able to pull out what you need. So I need to find the measure of angle RPV. So RPV. So that's really that triangle there. So first thing I'm doing is I'm pulling my triangle out of the mess. Now I'm going to need to use that messy picture to find some things. However, by pulling this out, once I start finding lengths, I can then just put them directly on here. Now none of those are the sides of the box. So I have the sides of the box. So I have a horizontal. Here, let me change colors. I have a horizontal of 6. I have a width of 5. I have a height of 3. So those are the heights that they gave me. Now the nice thing about this is all of those lengths that they gave me make up right triangles. So for instance, I can look right here in the front. This is 6, and this height is the same there, so it's 3. And now you have a right triangle. Like if you think about the front of the box, you now have a right triangle in there. So you can figure out what PV is. Oh, I wrote that wrong. That's P, sorry. So I can figure out what PV is. So I know 3 squared, leg squared plus leg squared equals, let's just call that W. W squared. So therefore W is just the square root of 45. So W was PV. So that's the square root of 45. So one side down, 2 to go. Doesn't matter which ones you want to work with. Maybe I look at this one because I can easily see. This is 5, this is 3. There's that 90-degree angle in there. Now that's the side of your box. So that again is a right triangle. So 5 squared plus 3 squared, leg squared plus leg squared equals hypotenuse squared. We'll call that one X. So therefore 5 squared plus 3 squared equals X squared. That's 34. So X is the square root of 34. So that was here. And then the last one that we have to find is the one that's on the top. So I need this length, which is made up of this horizontal, which we know is 6, and this length here, which we know is 5. And this is a right angle. It's the top of your box. Like think about that top, the back side and the left side. That forms a 90-degree angle. So therefore, 5 squared plus 6 squared equals, I'll call that Y. Y squared. So 5 squared plus 6 squared, that's 61. So the square root of 61 is Y. Again, my goal is to find an angle. But in order to find that angle, I had to find all my sides. But now that I have 3 sides, if you remember from yesterday, now we're just going to be doing the cosine rule. So if I have 3 sides and I need an angle, I find the cosine rule. If I have 2 sides and I have 1 angle, depending on which 2 sides they are, again, you can use that cosine rule. So remembering what your cosine rule is, and it's completely based upon the angle that you want. So this is the angle that I need. So therefore, the side across from that, the square root of 34 squared, equals each of the other 2 sides, 45, square root of 45 squared, plus the square root of 61 squared, minus 2 times each of the sides. I'm so not going to have enough room. Sorry about that. Minus 2 times the square root of 61 times the square root of 45 times the cosine of the angle I need, which is that P. So going through and simplifying, it's really nice by keeping these as square roots instead of decimal approximating them, because the square of the square root of 34 is just 34, 45, 61. Now minus this, so this is 2, so 61 times 45 is 2,745 times the cosine of P. Subtract those guys over, and you end up getting 36. And hold up, let me just slow down just a smidge. So that gives me negative 72 equals negative 2 times the square root of 2,745 cosine P. Remember, I cannot add this and this together because it's attached to the cosine of P. And then I can divide both sides by that negative 2. I'm just working with my nice numbers, so I don't have to grab my calculator out yet. And so at this point, I'm going to have to go to my calculator. I'm going to have to divide both sides by the square root of 2,745, which just gives you 0.687 equals the cosine of p. Now, if you remember back from when we were talking about unit circles, you know that when you look at the sine cosine of an angle, that ratio is always between -1 and 1. So if that decimal was more than 1 or less than -1, this would not be possible. This triangle wouldn't exist. So now I take the inverse cosine on both sides to undo my cosine, and p therefore is approximately equal to 46.598 degrees. So the picture in this one was pretty ugly to start, but then once you just start looking at it, it was just right triangles to find those lengths, and then obviously you had to do the law of cosines, which was part of our practice work that we're trying to do. Okay, then the last example that we have, this one is dealing with bearings. And bearings always go from north. And then they always go clockwise. Unless they start talking about some other pieces of information, bearings always start from the north and go clockwise. So we have a hiker that leaves camp. So here's my hiker. This is where he's starting. And he leaves camp and walks on a bearing of 87 degrees. So because it goes from the north, always draw in that northern direction. And so from the north, it's 87 degrees. So this is 87 degrees. So that's the direction he's walking, and at that speed. We'll have to take that into consideration in a minute, because that speed's going to give you your distance. And then we have another hiker that leaves the same camp at 12:15. So he's also starting here and walks at a bearing of 137 degrees. So this is 137 degrees-ish. And he walks that direction. Okay, so I know that big angle is 137. Now what might be helpful is instead of doing the big angle, because it just starts to get messy in terms of some of the work, drawing in what that actual angle is. So if the whole thing's 37 and this one was 87, that means between these two guys, there's an angle of 50 degrees. And I'm just going to draw that in here without that. Does that make sense? So 137 was the whole thing, 87 was the first guy, so we find the difference, which is that 50 degrees. Now I need to find my lengths on here, because the one walked at a speed of 3 kilometers per hour, he really took a nice stroll, and the other one's walking at 8 kilometers per hour, like pretty brisk pace. And we want to figure out how far they are apart. So since one started at noon, he walked until 2 p.m., that's 2 hours. If he walked at a speed of 3 kilometers per hour, his distance then is 6. And then the other guy, he's walking for an hour and 45 minutes, which is 1.75. And he's going at a speed of 8 kilometers per hour. So 1.75 times 8, that's a little bit longer. That is 14. And we want to know how far apart they are at that time. So the bearings part gets your angles done, and now you just have a non-right triangle. If you need to, if your picture gets too messy, just rewrite it. 6, 50, 14, x. Oops, that's degrees. Now all you're going to need to do is do the cosine rule, because you have two sides and an included angle, and the side that you have is the one that's across from the angle. So therefore, x squared equals 6 squared plus 14 squared minus 2 times 6 times 14 times the cosine of 50 degrees. Again, make sure your calculator is in degrees. Now my x is on the left-hand side all by itself. So I can just directly type into my calculator, and I get the following decimal approximation. Keep that value exact, square root it, and you get 11.136 kilometers. Again, applications, it's just the picture that you have to be able to either draw or analyze, and then right now we're doing law of cosine and law of sine rules. One more note for you. This one only had a single bearing in it. In your homework, you're going to get one that has 2 bearings, so I want you to understand how to write that out. So if we had, say, a student decided to go for a walk, and she decided to walk on a bearing of 45 degrees. Okay, and she walked for, I don't know, however long, doesn't matter. And then at a certain point in time, she decided to change the bearing or change the direction that she was going, and now she decided to walk on a bearing of 140 degrees. And then we can look at like, well, hey, how long could she have walked from the beginning if she just went directly there? Some of those kinds of things. But here's the important part. So if she walked at a bearing of 45 degrees here, and then this one here we said was 140 degrees, these are parallel lines, right here. These are parallel lines. In between parallel lines, those two angles add up to be 180. And then we have corresponding angles, which are the same. So if I have this transversal, so if this transversal kept going, this is 45 degrees, this is 45 degrees. Okay, but that's not going to help us in this picture. The part that's going to help us in this picture is this angle right here. So because this was 45 degrees, I know that these two are same side interior, which do add up to 180. Therefore, this angle right here is 135 degrees. The nice thing about that is because you know this is 135 degrees and you know this is 140 degrees, you automatically know that angle that's inside your triangle. So when you have double bearings, you do, or even more, you do have to look at parallel lines, and you have to remember all those things from geometry. In between parallel lines and a transversal, because that's what we have, parallel lines, transversal, what different types of properties do we remember? And then the other one, I kind of hit on it in the first example, is if you have pictures within pictures, so you have a triangle and you have another triangle, a lot of times it is easier to pull them apart, but you do have to remember that they always shared that side. And that shared side is typically what's going to help when you start working with one triangle and put the other one with it. Okay, so for your homework problems, you have these 5 problems to be working through. Please take your time and draw the picture. I highly recommend after you draw the picture, check your answers, and then go from there. Because if your picture's wrong, then nothing's going to kind of work out. Good luck.